Alright, so here is the challenge problem from the last video. And for part A, we want to know what happens to the distance of separation of the boxes. So I'm going to begin by drawing a little picture. Here's the airplane. Here's a box that was dropped 5 seconds ago. Actually, let me make that farther down because it's been falling. And then here's the box that was just dropped. Alright, so horizontally, these boxes are going to stay the same distance apart. However, this box right here will always be traveling faster than the one that was just dropped. And because distance equals velocity times time, if this one is always traveling faster than this one, their vertical distance of separation will be increasing while their horizontal distance of separation will stay constant. So the answer to part A is it will increase. Alright, part B, how long does it take each crate to reach the ground? So we're going to make a chart for our x direction and our y direction. So the initial velocity in the y direction for the box is going to be 0 because it's dropped from the plane. And we don't really need to worry about the horizontal direction for this part. We don't really know its final velocity, but we know that its change in position in the y direction is 200 meters because that's the altitude at which each box is dropped. Its acceleration in the y direction, let's call downwards positive. So it'll have an acceleration of 10 meters per second squared. And we want to know how long it's going to take to reach the ground. So we need an equation that does not have the final velocity in it. So let's use change in vertical position equals initial velocity times time plus 1/2 acceleration change in time squared. Since initial velocity is 0, this cancels out of the equation. So now we can solve for time to get 2 times change in y over acceleration and then take the square root of that. So if you substitute in your values, that would give 2 times 200 divided by 10. Take the square root, and you can plug that into a calculator to get approximately 6.32 seconds. Alright, and then for part C, we want to know how far apart will the crates land on the ground from each other. So in that case, we need to do the horizontal part of this chart. So this airplane is going to be traveling at 50 meters per second when it drops those boxes. That means they're going to be going horizontally at 50 meters per second. And there is no acceleration in the x direction. And we want to know how far apart they'll land from each other, so we want to know change in x. And we also know that they are being dropped every 5 seconds. Alright, so let's say we drop this crate, and then we drop this crate sometime later. This distance between them is going to stay constant because they're not accelerating in the horizontal direction. So we can use position equals velocity times time to get part C, and that will say the distance they each land apart from each other will be 50 meters per second times 5 seconds. See, our seconds cancel out and we get 250 meters. So that is the answer for part C. So in this video, we're just going to be looking at AP Physics 1 practice questions with the kinematic equations and parabolic motion that we've been studying. So in this problem we have a cliff diver who runs off a cliff with a horizontal velocity v and lands a horizontal distance x from the base of the cliff. How far would the cliff diver have landed if he had been moving with an initial horizontal velocity of 4v? So we are looking at motion in the horizontal direction, and that means because this cliff diver is in free fall and we have no acceleration in the horizontal direction, that the velocity is going to be constant. So we can use this equation, position equals just velocity times time. So initially he lands a distance x, and now we are going to quadruple his horizontal velocity, so we have 4vt. Now what we have to do is look at this variable t here. Is that going to be the same, or is that going to be different value now that he's moving at a horizontal velocity of 4v? If you're not sure, you can just make a little kinematics chart for the vertical direction. So we have these variables, right? Now in both situations he's running off the cliff, so he's going to have an initial vertical velocity of 0 meters per second. He's going to travel the same distance change in y with the same acceleration, and because all of these variables are the same, by the equation position, change in position equals initial velocity times time plus 1/2 at squared, these variables here are staying the same, thus change in time is going to be the same for each case of these two scenarios. So that just means he's going to travel a distance of 4x. So that tells us that when the horizontal velocity quadruples in this situation, then the horizontal distance traveled also quadruples. Projectile has a horizontal velocity vx, vertical velocity vy, and vertical acceleration a. When the projectile is at the peak of its trajectory, which of the following is true? So we're launching a projectile maybe that follows a path like this, and we want to know which of the following is true at the peak, so at the top point. Now remember, at every point in its trajectory, this projectile has an acceleration of the same magnitude towards the center of the planet. So that means it has the same acceleration here, 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 in the vertical direction acting towards the center of the planet. So that means it has to have an acceleration at that top point. So that rules out choices B and D. Now, this is a projectile, which means it's in free fall, and that means the only force acting on it is due to gravity. There is no horizontal force of gravity for this projectile. So that means its vertical velocity is going to remain constant, which is true in choices A and C. Vertically, however, we're launching it with some velocity v sub y, and that is slowing down because gravity is acting in the opposite direction to that initial vertical velocity. So by the time it reaches the peak, it has 0 vertical velocity, after which point it turns around and its speed increases on its way back down. If we're defining up to be positive, then vertical velocity would become negative. Anyway, that makes choice C the correct answer. The ball is released from rest and travels a vertical distance y during the first second. How far will it travel during second 2? So this is a bit of a trickier problem, and to solve it, we are going to take the distance it's going to travel during both seconds, so change in y for 2 seconds, minus the change in y for second 1, and that will give us the change in y just during second 2. Alright, so we want to figure out how far is it going to travel during both seconds, and that is going to be our change in y2. So we have an initial velocity of 0 because this ball is released from rest. We don't know its final velocity. We know it has an acceleration due to gravity of g because it's released from rest, so it's a projectile in free fall. We don't know change in y yet, and we are going to look at the time interval of 2 seconds. So how far would the ball fall during both seconds? Right, so we're going to use the kinematic equation delta y equals initial velocity times time plus 1/2 at squared. Alright, so delta y for both seconds, this becomes 0, is going to equal 2g. Now we want to figure out what does delta y equal just for the first second. And now we're going to be looking at a time interval of 1 second. So now delta y, this term here still becomes 0, equals 1/2 at squared, and that equals g over 2. So now we have the delta y for both seconds and the delta y for second 1. So if we subtract these two values, that will give us the change in y for just second 2, and that's what we're looking for. So we can rewrite this as 4g over 2 minus g over 2, and that equals 3g over 2. Right? But we just want that in terms of y. Well, lucky for us, we already have that answer. This delta y here is just for second 1, and this equals the y in our problem. So if we can take this value here, replace it with y, that tells us our answer is going to be 3y. Right? So during second 1, it's going to fall a distance of y. But during just the second, it's going to fall a distance of 3y, and that would basically tell us that its total change in y for 2 seconds is going to be 4y, because you would just add those 2 seconds together. A ball is thrown upwards with an initial velocity of 5 meters per second. After 1 second, which of the following would show the direction of its velocity v, displacement y, and acceleration a, where acceleration due to gravity equals 2 meters per second squared? Alright, so remember that displacement is a vector, so as long as the object is above its initial launch position, displacement will be positive, or you could say upwards. We can compute that with the equation displacement equals initial velocity times time plus 1/2 times acceleration times change in time squared. Substitute in values, so that would be 5 times 1 plus 1/2, and we're going to call upwards positive, so that would give us an acceleration of -2, because acceleration points towards the center of the planet, times 1 squared, and that would give us a delta y of 4 meters above its launch position, and that would be upwards, so we can rule out choices B and D. And if we look at choice C, notice that it says that its acceleration is going to be upwards, and we clearly know that is obviously wrong. So that means choice A is the correct answer. And if you wanted to double check that to make sure, you can use the equation that final velocity equals initial velocity plus acceleration times change in time. Substitute in values to get 5 plus a -2 times 1, which will give you a velocity of 3 meters per second at this time. So that tells us that its velocity after 1 second is still going to be upwards. So that means choice A is correct. Alright, here's the challenge problem for this video. 2 balls are thrown upwards in the same gravitational field. Ball B is thrown with twice the initial velocity of ball A. How much higher will ball B go than A? The solution will be on my Instagram page, link in the description, 24 hours after posting this video, or you can find it at the beginning of the next video.